Topic 15.4 Impact. Today's objective, students will be able to understand and analyze the mechanics of impact, analyze the motion of bodies undergoing a collision in both central and oblique cases of impact. We will limit ourselves to only central impact. We won't talk about the oblique impact for now. When the motion of one or both of the particles is at an angle to the line of impact, the impact is said to be oblique impact. The ratio of the restitution impulse to the deformation impulse is called restitution coefficient. We will learn this during the presentation. So let's look at the application of an impact. So an impact is when one object collides with another object for a short period of time. It's called an impact. So the quality of tennis ball is measured by the height of its bounce. This can be quantified by coefficient of restitution. So for any ball that involves games such as tennis or baseball or cricket or golf, the quality of the ball matters, and the quality of ball is quantified in terms of coefficient of restitution. If the height from which the ball is dropped and the height of its resulting bounce are known, how can we determine the coefficient of restitution of the ball? So let's take this example to understand it. So the boy is holding the ball in his hand. So initial velocity of the ball at this point is 0, and then he releases the ball. He's not throwing it, he just releases it, and as a result of the gravitational attraction, the ball falls on the ground and hits the ground with some velocity v1. Let's call this distance from the initial release as s1, so which is 1685 millimeter or 1.68 meters, and that ball hits the ground with some velocity v1. After hitting the ground, this situation is called an impact between the ground and the ball. After impact, the ball bounces up in the air and it moves up with some velocity v2, but as the ball goes up, the gravitational attraction reduces the speed of the ball, and at some point its speed becomes almost 0, so it stops going further up and then again comes down. But this is the point. Let's call this point as, this point also has like 0 v, this also has 0 v, and this height, let's call this height s2. Now based on this information, we need to calculate the coefficient of restitution, and that has been calculated as 0.81. We will learn how to calculate this coefficient of restitution, but for now we use small letter e to define coefficient of restitution, and which is nothing but the ratio of the velocity of a particle after impact to that of before impact. It's very simple ratio. Now this is an impact between the ball and the ground, and in both the cases ground has 0 velocity, so we can simply take the ratio of velocity of the ball after to before impact. The more accurate representation of coefficient of restitution is the relative velocity of the ball before and after impact. But we don't consider the relative velocity for now because the ground does not move in either case. So v2 by v1 is called the coefficient of restitution, and its value is in the range of 0 to 1. It can be 0, it cannot be 1, which is not practical. And let's see how can we calculate it. So in order to calculate E, we need to calculate v1, velocity with which the ball strikes on the ground, and v2, the velocity with which ball moves up so that it reaches 1100 millimeter height. So let's calculate this here. Now this is the equation v square equal to v0 square plus 2as. We are familiar with this equation from chapter 12, which is kinematics of particle. Now this is the case of straight gravitational attraction, so we can say that v square equal to v0 square minus 2 or plus 2, if we assume, let's say, going down is positive, then gravitational attraction is positive. So 2gs, where g is gravitational attraction, acceleration. So let's apply this equation to first situation. This is situation number 1, where the ball goes from the hand of the boy to the ground and hits the ground with velocity v1. So this is the final velocity of the ball. Initial velocity of the ball here is 0. So in this equation, the initial, if we apply that equation to situation number 1, this equation, then it can be written as final velocity of the ball v1 square equal to initial velocity plus 2 times 9.81 times s1, where s1 is this height from where it's being released. So v1, in other words, is square root of 2 times 9.81 times s1. Now let's apply that to situation number 2. After the ball hits the ground, it moves up with velocity v2. So if you apply this equation here, then v2 becomes the initial velocity of the ball after impact, and this becomes the final velocity of the ball after impact. So for this formula, it will be v2 square. So it will be v square equal to v2 square plus 2 9.81 times s2. Again, we assume that gravitational attraction is positive because it's going down. For this problem, because the s2 displacement is in upward direction, that term will be negative. So when we substitute this formula here, we should write s2 as minus s2 because the ball goes up and down is positive. Final velocity of the ball here is 0 when it reaches this height. So this term is 0. And since this is negative, it will become positive when we move that to the other side of equal to sign. So it's 9.81 times s2. So that is v2 square. That means v2 is square root of 2 times 9.81 times s2. So now coming back to coefficient of restitution equation, E is equal to v2 divided by v1, which is square root of 2 times 9.81 times s2 divided by v1 is also square root of 2 times 9.81 but multiplied by s1. So these numbers will cancel out. So what we are left with is square root of s2 divided by s1. That is the height with which the ball bounces up, which is 1100 divided by 1685. Okay, and that is 0.81. So that is coefficient of restitution. So that's how it's being calculated. So see how we have applied kinematics equation to calculate the velocity of a particle or ball when it is dropped off from certain height and it hits the ground. Okay. In other words, very simple definition of coefficient of restitution of this ball is nothing but the ratio of velocity after impact to before impact. For this particular problem, it is ratio of height it bounces after impact to that of height it is released before impact. Okay. And now you can see that why does the value of E can never be 1, because if E is 1, that means S1 is equal to S2, and that doesn't make sense, because if you release the ball from a height without forcefully throwing it on the ground, it will never bounce back to the same height. There is always loss of energy at this point, at the impact, in the form of heat, in the form of localized deformation, and in the form of sound. And because of that loss, the ball will always rise lower than the height from where it is being dropped. So that's why E can be 0, but it can never be 1. So now we can go back to presentation and look at a few more slides. Okay, so this slide it shows different coefficient of restitution values for different balls. You can see that the red one is for the tennis ball, which bounces back to much more height after being dropped off from this height, while on the other hand, cricket ball, it only goes like very little after it hits the ground, and the golf ball is somewhere in between. Now, types of impact. In the game of billiard, it is important to able to predict the trajectory and speed of the ball after it's struck by another ball. If we know the velocity of ball A before the impact, how can we determine the magnitude and direction of velocity of ball B after impact? So this is a tricky question, because if we know the velocity of ball A before impact, we can predict the velocity of ball B after impact, provided that we also know velocity of A after impact, or we have some idea about the relative velocity of A and B after impact. So for that, we need to know the coefficient of restitution between these two balls, E. So if we know coefficient of restitution, and then we can apply this equation, sigma mivi1 equals sigma mivi2, that is conservation of momentum. Using these two equations, we can predict the velocity of ball B. So impact occurs when two bodies collide during a very short time period, causing the large impulsive force to be exerted between the bodies. Common examples of impacts are a hammer striking a nail or bat striking a ball. The line of impact is the line that passes through the mass center of colliding body. In general, there are two types of impact. So this point here is the center of mass of ball A. This point is the center of mass of ball B. When we draw a line that passes through them, it's called line of impact. And the plane perpendicular to line of impact is called plane of impact. Now, depending on the direction of the initial velocities of two objects, the impact can be classified as central when there's then line of impact passes through center of mass, or where the line of impact does not pass through center of center of mass. So initial velocity of both the balls are at a different angle. So this type of impact is called oblique impact, and when it's straight line, it's called central impact. And during the impact, there is localized deformation that happens here, and that impulse is called deformation impulse. Now we are familiar with this equation, conservation of linear momentum, that total momentum remains constant. Now if we know velocity of ball A and ball B before impact, then we cannot predict both of this after impact, velocity of ball A and ball B, because then we will have two unknowns in one equation. So we need another equation, and that another equation is the equation of coefficient of restitution. So coefficient of restitution is written as velocity of object B relative to A after impact divided by velocity of object A relative to B after impact. Now we are familiar with this relative velocity notation, that this can be written as VB2 minus VA2, and this is VA1 minus VB1, and that's the equation for coefficient of restitution, where this is absolute velocity of B minus absolute velocity of A after impact divided by absolute velocity of A minus absolute velocity of B before impact. So again, this is after impact and this is before impact. And depending on the value of E, an impact can be classified as elastic impact, where value of E is 1, which is perfect collision, no loss of energy. In practical situation, this condition cannot be achieved. It's like throwing a ball from a height and the ball bounces back to the same height. Plastic impact, it's an impact where the relative separation velocity is 0. That means either the two objects will move together with the same velocity, or if you throw an object which hits the ground, it does not bounce back at all. And for that, the impact coefficient of restitution will be 0. These are typical values of coefficient of restitution for different objects. So if you have steel ball colliding with steel ball, this is the range of E. Highest range is for glass on glass. So if you have two glass marbles, they collide with each other, there is minimum loss of energy between them, and that's why the highest value of coefficient of restitution. And this loss of energy can be calculated using kinetic energy equation, that the loss of energy is nothing but the kinetic energy of the system after impact minus kinetic energy of the system before impact. And oblique impact, we don't talk about this for now. You can skip this part from the presentation. In the next video, we will solve a problem involving conservation of linear momentum and coefficient of restitution problem.